Good day, ma'am. Today, I am going to discuss the osmoregulation of the three aquatic organisms. First is the marine teleost, second is the freshwater teleost, and lastly, the marine mammals. In each group, I am going to explain the osmolarity, tonicity, ions and water movements, the problems they face, and the solution or the mechanisms they use to survive. Now let's begin with the marine teleost. And as for the osmolarity and tonicity of the marine teleost are hypoosmotic to seawater. This means that their internal salt concentration is lower than its surrounding, which is the salt water. This means that a marine teleost lives in a hypertonic environment, making marine teleost as hypotonic. For the movement of water, water moves or tends to leave their body through the process of osmosis. And for the ion movement, salt ions such as sodium and chloride diffuse to the body of the marine teleost. And as for the problem that the marine teleost commonly face, they are at high risk of dehydration due to water loss and overload of salt or salt overload because of the ion gain. And in order to resolve this problem, marine teleost drink a large amount of salt water and actively excrete excess salt through their specialized chloride cells in their gills and through their urine, which is very concentrated. Moving on to the freshwater teleost. And as for the osmolarity and tonicity of the freshwater teleost are hyperosmotic compared to its environment. This means that their body fluid are saltier than its surrounding. Therefore, a freshwater teleost are hypertonic that lives in a hypotonic environment. And for the water movement for the freshwater teleost, water constantly moves through their body through the process of osmosis. And while for the ion movements, essential salt diffuse out to their body. And as for the problem that the freshwater teleost commonly face is they are at the high risk of water overload and salt loss. In order to resolve this problem, they do not drink water. Instead, they excrete a very dilute urine and actively absorb salt through their gills to replace the lost ion. Now moving on to the last group, which are the marine mammals. For their osmolarity and tonicity, marine mammals are roughly isosmotic internally compared to other terrestrial mammals. But relative to seawater, they are still hypoosmotic. And as for the water movement, marine mammals do not directly lose or gain water through their gills. Instead, it is from their diet and environment. For the ion movement, marine mammals ingest salt or ions through food or seawater. And for their problems, marine mammals are at risk for salt accumulation and water loss in salty environment. And in order to resolve this problem, they rarely drink seawater. Instead, they rely water from food and metabolic processes. Their kidney are highly efficient, producing a highly concentrated urine to remove excess salt while conserving water. In summary, marine teleost battle with dehydration and salt gain, solved by drinking water and excreting excess salt. Freshwater teleost face water overload and salt loss, solved by excreting dilute urine and absorbing salt. Marine mammals handles a balance of salt and water through efficient kidneys and metabolic water. Therefore, osmoregulation is the key mechanism that allows these organisms to thrive in the different aquatic environments.